I had a wonderful experience while I was teaching machine learning to a group of people. Now, in this group, it was a mixed group. There were newbies, fresh newbies who does not know what machine learning is, and they wanted to just have a basic introduction to machine learning. So one of the people in that group said, "Hey, can you tone it down a little bit and explain machine learning to a 5-year-old?" All right. So I use an example on how we cook a Thanksgiving turkey, since this is the Thanksgiving season, to explain machine learning, specifically hyperparameter tuning. So sit down, relax. In this video, I am going to share with you how hyperparameter tuning can be explained with the way we cook a Thanksgiving turkey. Yes, that turkey that sits in your oven for 5 hours while your cousins ask if is it ready yet. That's what you're going to use in this example to explain hyperparameter tuning. Okay, so what are hyperparameters? In machine learning, hyperparameters are the settings that you choose before training your model. Basically, we're talking of the learning rate, the batch size, and epoch. Those are the three main ones. So in the context of Thanksgiving turkey, these are factors that contribute to the quality of your turkey, which can be one, the oven temperature, how often you check it, and how much seasoning do you use. So the oven temperature in our case will be the learning rate. How often you check it will be the batch size. How much seasoning you use will be your epochs. So those are the three main items: learning rate, batch size, and epoch. Now we're not going to deep dive in the official definition. We just want to make it fun and light. All right. So learning rate, we said, is oven temperature. The learning rate controls how big each step is during model training. That's the official explanation. So I want you to think of it as like your oven temperature. If the temperature is too high, or if the learning rate is too high, your turkey will burn inside and still remain raw. Will burn outside and will be raw inside, and there'll be smoke everywhere. Yet the turkey will remain uncooked. So in machine learning, this is your model overshooting, wild jumps, zero stability. Now, if your temperature is too low, the learning rate is too low, your takes forever to cook, then everyone becomes hungry, or angry rather, then its dinner starts a day after Thanksgiving. This is slow training. The model learns painfully slow. We want our model to use optimum time and optimum resources. So what is the perfect temperature? The turkey cooks evenly. There's juice inside the turkey, is crispy outside. That's the optimal learning rate, smooth and steady learning. That's what we want. So whenever you have issues with your model, overshooting and underlifting, one of the areas that you may want to look at is your learning rate. Okay, let's look at the batch size. In Thanksgiving turkey, we can think of it in terms of the size of the spoon. All right, how much you apply the turkey drippings on the turkey as you cook it. In machine learning, batch size is how many samples of models the model uses per update. So how much butter, how much juice do you burst at one time? Are you going to take 10 spoons to splash over the turkey, or you're going to use 3 or 4? Small bursting means small batch. Yet small bursting are very good because they're very precise. You burst often, it takes more time. Small batches are often kind of stable, but there's a slower learning to it. Now, if you use a larger burst or larger spoon, you can make splashes everywhere, just like you do in turkey. Your turkey may also end up soggy. You want the turkey to have this texture that is spot on. So large batches, which is basically faster training, they are good in faster training, but they lower the accuracy. All what we need is medium bursting, basically an ideal balance in how we apply the soup on the turkey. All right, epoch, the third and our last concept here. How many times you check the turkey? So depending on the weight of the turkey, sometimes the turkey, if you're baking it, can take up to 5 hours, sometimes 3 hours, depending on the size of the turkey. So in machine learning, an epoch is one complete pass through the training data. For our Thanksgiving turkey, an epoch is how many times you check your turkey before declaring it done. So the definition of done, before you declare done, how many times are you going to check your turkey? You can have intervals of 1 hour, if it's perfect for your turkey, depending on the size of the turkey and the temperature and everything. You might have 2 hours or 2.5 hours. There might be too few. So too few checks or too few epochs, you pull out your turkey raw. Then the family will ask you, are you okay? You are basically, in a machine learning language, you are underlifting. Too many checks or too many epochs, you open the oven door for every 5 minutes. Now you compromise the quality of the turkey, because the more you open the door of the oven, heat escapes. Then the turkey dries out. You want to lessen the number of times you do your epochs. So basically, if you have too many epochs, you are basically overlifting. The turkey gets worse the more you mess with it. All right. So let's tie everything together. three concepts in hyperparameter tuning that you need to master to make sure that your model is accurate are the learning rate, the batch size, and epoch. In our text-giving example analogy, we're talking of the oven temperature, learning rate, bursting amount, or the batch size, and the epoch, which is your checking frequency. Master this, then you can apply these concepts in every machine learning concept that you can have, machine learning problem that you can use, that you can find yourself working on, any machine learning model that you can find working on. All right, that is that a simple analogy that can help you understand these concepts in a very simple, basic layman terms. Thank you and bye-bye.